Hello. On behalf of Hyperion Research and Inside HPC, I'm Dan Olds, and we're going to be interviewing Dr. Jeffrey Broughton today. Did I pronounce your name right?
It's Broughton.
Broughton.
I'm actually not a PhD.
Oh, you must be by now, at least through association with so many.
Yes, but
you've been pretty much everywhere. So let's talk about that. Let's talk about the course of your career and how you got started in HPC.
It started actually back in 1979. I went to work at Lawrence Livermore National Lab on a project called the S1 project, which was an attempt to develop and design literally from scratch a high-performance computing system that at that time would have been in the tens of megaflops range.
It's a pretty big number back then.
It was a pretty big number back then. And the project actually kind of was everything from soup to nuts. We actually developed the CAD technology to design the machine. We developed a number of architectural innovations that are now, many of which are now seen in traditional processors, although in much more elaborate forms. And we actually physically built the machine as well. My responsibility originally was working on the software for it, but ultimately moved into a management role.
That's a big project for a young man.
Yes, it was.
So what happened next?
So after about a decade there, I left and went to work in industry, joining a startup called Key Computer, which was also targeting at doing a high performance processor. As many of the folks from the earlier project decided it was about time to go out into Silicon Valley and make our fortunes. Key lasted as an independent entity, I don't know, I think maybe about a year and a half or so, and we were acquired by Amdahl Corporation.
Oh, okay.
And went on to, this was a time when risk was big, and went on to do some internal developments at Amdahl, which ultimately, truthfully, never saw the light of day, and as many acquisitions happened. And I stayed at Amdahl for many years, both in a technical role and actually spent some time on the dark side in marketing as well.
Oh, no, don't say that. That tainted you.
I'm sorry.
At least for a while.
I saw the light. I saw the light. I came back to the path, of straight and narrow path. And after that, I went to work for Sun Microsystems for about 3 years. We were developing a massively parallel simulator that the purpose was specifically to do logic simulation for future generations of Sun systems. And it was actually a thing to behold because it was a massively parallel simulator. We were actually able to get about 80,000 way simulation.
Oh, wow.
80,000 way parallel simulation for the of the logic, which of course itself is massively parallel. But it was actually truly a thing to behold. But this was a really interesting machine because it was individual processors had no more than 4,000 instructions. There were just a lot of them.
Yes.
And it had a network between it, but it was entirely statically scheduled by the compiler.
Okay.
So it was a really interesting project. Had some benefits internally, but I left and went off at that point and became a founder of Pascal.
Oh, yes, I've heard of Pascal.
Yes. So Pascal was kind of interesting. So we were looking at building technology for high performance computers. We had somewhat more grandiose plans to cover the entire spectrum, but we started by doing compilers and the niche we were looking at was to do compilers for AMD. And we brought in
Okay.
a team and actually adapted the SGI compilers, which at that point were open source, and applied it to the to AMD systems, and actually were able to achieve quite good performance on that, and also on Intel machines. But the major part of it is we thought also we're developing a high performance computing interconnect. And we ultimately ended up targeting InfiniBand, so we became the alternative to Mellanox.
That's what I remember. Yeah.
But it had some secret sauce in it that was designed for extraordinarily low latency. We actually went through, well, I was there 3.5 generations of interconnect till we were finally acquired by QLogic. And I stayed with QLogic for a number of years before deciding to go to work at NERSC.
Okay.
Was, actually rather refreshing. So instead of being a vendor getting beaten up by the customers, I could be the customer beating up the vendors. So I have
much more fun, isn't it?
Much more fun in many ways. So I've been at NERSC now for about 11 years. Taken on a number of roles. I was originally head of the systems department, completed the installation of the Hopper machine, which was the first petaflop machine at NERSC. Then I was ran the procurement of the Edison machine, which was the first, literally serial number 1 of the Cray XC series. And then later on, I actually took over responsibility for building the new our new data center on the LBNL main campus, and brought up our new data center there, and have been working to expand that ever since.
Wow, fantastic track record. So, what are some of the biggest changes you've seen in HPC over the years?
You know, the interesting thing I think about HPC is that in many ways it hasn't changed a whole lot. And you know, if you look at the people who have been involved with it, it seems, you know, people become enamored of high performance computing. And although some of the people have moved from vendor to customer, from one site to the next, you know, many of the leading people in this have really been in it more or less continually, in many cases, for decades in one form or another. And
it's
so
a close-knit community.
It's a close-knit community, and with really much of the same goals associated with it. So in that sense, I don't think it has really changed a whole lot. I mean, certainly technology has evolved, right? We went from the highly specialized machines into leveraging the commodity infrastructure. In fact, I would say that's probably the single biggest change that I have seen from going is the introduction and leveraging commodity technology with a little bit of specialized magic here and there to make it actually work. So,
do you kind of see us heading back towards the specialist route with so many processors under development now? They're specialized for single purpose.
I think the commodity-based systems have a lot of life left in them. But I think there is tremendous opportunity for some of the specialized processors that we're seeing, especially in the machine learning area. That will come to fore.
Both training and inference.
Yes, and I think NERSC's general view is that what we're going to start to see is large supercomputers that have a variety of processing elements in them that are tuned to different things. GPUs, especially for large-scale simulation of the sorts we've seen, commodity processors with lots of I/O that'll be applied to data analytic test technology, and then, as I say, it's the specialized things, either FPGAs, custom
Sure.
processors, or application-specific processors, and that those will actually work. I think are going to turn out that having for some of the more complex, especially the large experimental
Hmm.
projects, having that mix of capabilities within a single tightly knit computing complex will be very beneficial.
I totally agree. And that's kind of the way I see it going as well.
Mhm.
So, looking down the road, do you have any concerns about where HPC is going? Anything that needs to be avoided, for example?
Interesting. Um,
Any trends that you think might be wrong directions that people are tempted towards, for example?
um, well, I tend not to be a pessimist, so it's hard to say that there's anything I'm really uh, particularly afraid of. Um, I do think maybe that we have come to the end of the usefulness of the top 500 list.
Mm, mm,
Um, I mean, it, you know, it, the exascale project has accomplished an enormous amount to push us forward, but it's also an enormous investment,
yeah,
part of the Department of Energy, and well, I think there are places for singular, very large machines. Um, I think, having, as I talked about earlier, having things which have more diverse capabilities um, are very important. Um, to kind of go to the flip side, what really encourages me?
yeah, that's what I want to hear next.
Well, I think one of the fallouts of the exascale process is you really can see the notion of having petaflop machines that sit in one or two the size of one or two conventional racks that'll cost less than $1 million. And heck, that looks a lot like a VAX in some
Yeah,
ways,
yeah,
right? And the ability to deliver that to organizations which may not have been able to own their own,
sure.
$100 million supercomputer in the past may end up being very beneficial for science as well. Um, of course, we get into the areas of can you actually run a machine like that efficiently without having some uh, um, skill and how to
Yeah,
optimize for energy efficiency and so forth. That's a different question.
yeah. And it's interesting in that I guess some vendors are calling it the democratization of
Mhm.
HPC, but the prices have come down so fast for huge amounts of compute
Mhm.
that I think there is going to be some sort of a revolution there.
Yeah, well, certainly, I mean, GPUs have done an enormous amount for that as well.
Yeah,
Even small multi-way systems with a couple of GPUs. I mean, heck, that would have been unbelievable back when I started.
absolutely, absolutely, and it's such a change, right?
Mhm.
Um, and on your point about the top 500 list, I would like to see it split into about 5 different categories, like CFD,
Mhm.
Monte Carlo, different kinds of simulation, different kinds of compute,
Mhm.
memory intensive, IO intensive, uh, CPU intensive, that sort of thing. And let's do a list that way.
Mhm.
Does that make sense, or am I just crazy?
I think we have started to evolve the Green 500 list
Hmm.
as an alternative, but that's still basically an HPL
It's the same thing.
application. I
Yeah.
think there are probably having 3 or 4 metrics that target some of the areas that will be of particular interest. May well be. Um,
We might
and,
see an
and
AI list soon.
yes, for instance.
And there is an HPCG list out
Mm-hmm.
there.
Mm-hmm.
And that's a nice benchmark because it scales and it takes about half an hour to run just not depending on the system.
Yeah, I don't know much
Nice.
about that individual myself, so I won't comment.
Well, run on your laptop.
Yeah.
I think they've got a laptop version of it, or if they don't, Jack Dongarl spin one up. Well, this has been great. Thank you so much for your time. Really appreciate talking to you. And thank you all of you out there for watching.
Okay. Thank you very much.
Bye-bye.
Bye-bye.